a Kahoot. So a bunch of questions. I'm not sure if you're winning anything today or not. Margaret, do you know if we were, if there's any swag to be won? If not,
yes, for sure. With the Kahoot, yes. So top 3 winners.
Ooh, okay, top 3. So you're in with a chance. Okay, so getting started. I'll just share my screen, but then we'll hand over to Jorge. So right. So am I sharing something? Never really works properly. Okay, so not for me. Thank you for joining us. Thanks, John. Thanks for joining us, everyone. Today, we're privileged to have Jorge Martins, who's an OutSystems MVP, director and instructor at IT Up, and he's going to give us a bit of background about Agent Workbench on ODC, and then run a bit of a workshop where we can all have a go and use Agent Workbench. So just a bit of housekeeping. If you need to go to the toilet, you're in your own house or workplace, so you should be able to find it. Otherwise, I'm going to hand over to Jorge. Thanks, Jorge.
Thanks, Stuart. Okay, so what we're going to talk about today, and I do have slides, so apologies for that. Can't really live without them. Now I just need to find the right. Here we go. Okay, so these slides will be available. Margaret will make sure that you can see them. Where's my PowerPoint? There we go. Okay, so this is going to be like 8 slides, and it's going to give you a quick introduction to Agent Workbench in ODC and what it does and what are the... Sorry? Okay. What are the major parts of the agent workflow? So just quick agenda. What is agentic AI? How does it? What's the intention of building agents? What's the difference between agents and just pure software or regular software? Talk about the key concepts of that Agent Workbench works with. They're not just Agent Workbench, as you will see. A lot of them are just regular agentic AI concepts, but I will tie it with where you use them in Agent Workbench. I'll give you the gist of the agent flow and kind of connect it with the key concepts that I've mentioned before, and I'll give you a quick glimpse of orchestration. There's a final bullet there missing, which is there's a hands-on exercise. I'll give you a starting application, and I'll ask you just build some agents to fill in the blanks, basically. Okay. So first things first, agentic AI is basically, or agents are basically software that can decide, act, and iterate towards a goal. Okay, so a full agentic system can plan potentially multiple steps or make use of available tools to act, to do actions. If you have a good quality agent, or in order to have a good quality agent, you need to set up guardrails to make sure that they don't go haywire. And it's essential to define what's the scope, what are the limits, what are the approvals that may be required, because agents might be doing things that are actually risky. So you might want to have human intervention to make sure that the agent asks for confirmation before doing something that is actually dangerous. There's been a few recent incidents of entire production environments being deleted by the new agents that are out there. So let's try and avoid that by building agents that avoid those things. And equally important, make sure that you audit everything. So these are some of the major concerns that when you're building an agent, you will have to have. But overall, it is about we can read the room, for a matter of speaking. based on what we understand of our surroundings, of our context, make a decision. And if that decision involves interacting with other systems, the agent can actually do that as well. This is the major idea of agents. And it's not exclusive to OutSystems nor to Agent Workbench. It's how agents operate. Now, when it comes to agentic AI, the current iteration of agentic AI, typically the AI model is going to be the brains of the operation. This is the Gen AI model that the agent will be using, or large language model if you prefer. Keep in mind that requests to the AI model do not have any kind of memory or on past interactions. So this means that everything you need the agent to know is either parts of the original AI model training, so whatever ChatGPT knows, or needs to be part of the requests that you send to the agent, okay? Now, a few add-ons, because this is the location where OutSystems adds these configurations. When it comes to be able to act, I mentioned that agents can act. If you want to allow your agent to have autonomy in order to perform operations on your system, it could be write something to the database. It could be invoke an external system to do something. It could like execute something or fetch data from another system. You can configure the model with server actions that the agent can call. And each agent can have their own set of tools that they can call. So you can segregate what an agent can do by only allowing the tools that you're interested in. Okay. Based on the available tools, the agent will decide when to use them. And the way it decides this is based on the name of the tools and a lot of other metadata, like the names and descriptions of the tools, the inputs, and their descriptions as well. So based on all this information, based on what you asked, the agent will decide, oh, in order to perform this part of the request, I can use this tool to get the information that I need. And it will do it by itself. Okay? Finally, you can also instruct your agent to, instead of returning JSON, which is typically the output is going to be text in whatever format, but it's going to be text because LLMs receive text and return text as their outputs. If you want the output of your agent to be structured, as in you do have a way of organizing the data that the agent returns, you can set it up as well in the same place you configure the tool. So it's on the AI model configuration. You have the structured output, where is it? Sorry. Over here, where you can define what is the structure that is going to be used to represent the output. And OutSystems will be responsible for converting from whatever textual output the AI model returns into this structure. So of course, in order for this to work, your request needs to ask the agent or the model to return data using a certain format, like say JSON with two attributes. One is called name and the other one is called email, for instance. Okay, and these would be, if you say return this in JSON format with these two attributes, the agent would be able to, instead of just outputting text, it would output it in this format. So this avoids us having to do that afterwards. One thing of note, and this is a limitation imposed by Agent Workbench, currently, or actually by the way OutSystems is defining agents, currently you cannot configure both tools and the structured outputs for an agent. So if you want both, then you'll have to have two agents. One is responsible for using tools, and the other one would be responsible for the final output, and you would have to orchestrate them. Okay. Otherwise, you can choose one or the other, and you can test it directly on this screen. So this is the first important aspect here, is that the brains of agents currently are generative AI, namely large language models, and we can write questions to them. Which brings us to the second thing, which is the prompt itself. Victor, actually, supposedly lists are possible as well, but it has to be a list of a structure, if I'm not mistaken. Okay. I'm not sure, I haven't delved deep enough. They do mention lists on the documentation, that's for sure. I didn't see how to represent it, but when we choose the structured output, usually it gives us a structure choice. So we can select from one of the existing structures. But the documentation does mention lists. Okay, so prompts. The prompt is basically the request that we ask of the AI model, okay? And it typically is broken down in two parts. The first part is what we call the system prompt, and this kind of defines the rules of engagement. What's the agent's role? What's the behavior? Are there any constraints? And what's the overall goal or objective? Okay, this system prompt tends to be stable across multiple interactions with the agent. So if you ask different questions to the agent, we will provide the same system prompt, because this is what kind of gives the agent's personality and way of working. And then comes the user prompt. The reason why it's called user prompt is because in a conversational agent, for instance, this is actually what the user writes, okay? Our agents do not need to be conversational. We can actually write our own prompts internally in our applications, not coming from the user. But think of this as the question that we want the agent to answer, or the task that we want the agent to perform. This is typically a lot more dynamic and often user provided. The case of conversational agents come to mind, but also it could be that some of the information that we put on the user prompt is provided by the user directly. And we build dynamically the question that we want our AI model to answer. Now, a lot of the effort of building a good agent has to do with crafting the right prompts. So setting up the agent's persona, setting up the agent's goals, as well as carefully asking questions the right way. And you'll see when you start writing your own prompts, and we'll do that in a bit, that phrasing things slightly different can have different results, because the way the AI model thinks is a lot about how you write things. Okay, so we've seen that we have the brains, we have how to ask questions, but sometimes remember our agent, our AI model is based on information that it was trained with, right? Sometimes our organizations or the task at hand requires specialized knowledge, okay? And this knowledge is not something that your AI model that you're using has necessarily been trained with, okay? So grounding is the technique that helps us add more information to our request, to the question that we ask the AI model, in order to give it enough context to make the right decision. So we call this retrieval augmented generation, and I'm not going to go into too much detail here, but it is the idea is important here. So retrieval augmented generation, or RAG for short, is a technique that grounds your agent with data that is relevant to the request, or your prompt if you prefer. It can use one or more sources of information to provide the right context for your agent to think or to reason. And you can get information from OutSystems entities. So you can just, your aggregates can be used to fetch information that you're going to add to the prompt. It could be vector databases. If you have your information, if it's large amounts of information, you have it vectorized, and you can retrieve information that is relevant for the requests at hand. Or it could be other external sources via any kind of integrations that OutSystems supports. Okay, so all of these are going to be something that you can use in order to augment the question, the prompt that you want to pass on to the large model context. Okay. Now, retrieving relevant data from a knowledge base, usually based on the user prompt, is typically how this works. And we build the final prompt, including the system prompt, then the user prompts, followed by the relevant context that has been identified. And we feed all these things in one big request to the AI model. The result is an answer that is based not only on the AI model's training, but also on your own data. Okay, so that is the gist of retrieval augmented generation. Usually there's a lot of emphasis here on vector databases because they allow us to fetch information that is aligned with the requests without incurring the cost of calling agents or LLMs for that. But it's not necessarily the case. Okay, we can use any kind of source that we want. Finally, all our agents or LLMs in general are stateless, and this means that there's no knowledge of previous interactions. So, two different calls to the agent or to the AI model are two independent calls to the AI model with no knowledge of the previous one. So, if you want to keep track of a conversation, and this could be a conversation in the sense of we are chatting with our chatbot, or it could be that there's a sequence of interactions and we want to keep track of what happened already. Our agents will need to store memory, store information about past interactions so that we can later on use that information in future interactions, okay? So the idea is that we keep track of what was the prompt that we asked our agent, what was the answer the agent gave us, and when this happened, so that we can serialize them by when they happened. And once we have this, we can use this session context to further ground our information. Okay, so this is going to be also added as information that we pass on as part of the request to our AI model. Questions so far? Let me see. Can't really see where there are questions. Okay, so since I cannot see, I will rely on other people to let me know if there's any question that needs to be answered at the time. Okay.
There is a question from Victor. Structured output can be only a record, not a list, correct?
Yeah, that one I already mentioned. The documentation says lists or records or structures. The reality, I haven't tried with lists. Okay, so maybe it does, maybe it doesn't.
Explaining it so beautifully, Jorge, I think that's why there's no questions.
Or because people are still kind of sleepy.
Maybe.
End of the day. Okay, finally. So we've seen the major aspects here. And of course, there's a lot more to talk about in all of these things. But let's put this together. So Agent Workbench is basically a template of the flow that covers all these things. And we can see here on the screen what is generated automatically when we create a new agent. I just compacted it a bit to fit better on the screen, but these are the several different steps of calling an agent. And the first thing you notice is that it gets the grounding data. So it tries to retrieve information that is meaningful, that is needed to be context to pass on to our agent, to add on to the knowledge that they already have from the training they got. The second action there is called build messages, and it's the one that is responsible for building the prompt that we're going to send to our AI model, okay? And here, inside the build messages, that's where we're going to set up the system prompt, that's where we're going to set up the user prompt, and that's where you're going to also add the grounding data that we fetched previously. We're going to also add it here to the to the prompt. This is something that developers will need to do. There's locations where these things happen, but we can modify them at will. This is also where memory is going to be used. So part of the implementation of build messages relies on fetching the memory from previous interactions and add it to the system, to the prompt, so that we can so that the agent has more information. One aspect that is important to keep in mind here is that there's always limits to our agents, to our LLMs. When we call an LLM, there's always this thing called tokens that cost money and that we have a limited amount of. And whenever we grow our prompt, we are spending more tokens just asking a question, okay? And tokens, whether they are for the question that we ask or for the response that we get, they cost money, and at some point we will spend them all and we will need to buy more. So if we keep adding every single interaction that we've had in the past, we might end in a situation where our prompt is very big, and not only it spends more tokens, but it might actually reach a limit that exists for the prompt. So there's a maximum size for the prompt. It's measured in tokens, not characters. And I'm not going to detail what a token is, but it's somewhat related to parts of words. And that means that we won't be able to just shove all the information that we want from our grounding data, from our memory into the prompt. At some point, we might decide, depending on the data that we have, we might need to summarize things or to cull older conversation because we don't have enough space for everything and it's not meaningful for the conversation that we have. Okay, so keep that in mind. That is going to happen in the building the prompt section on the build messages. At this point, we have our our prompt defined. We can call the AI model. In this case, I was careful to change the name so it's generic, but it could be, currently I think the two trial models are Haiku, so Anthropic's Haiku and Amazon's Nova Pro. These are the current trial available. There's plenty of other AI models that you can add if you have subscriptions to them. So this is any of those AI models, okay? Depending on the AI model that you're using, the prompt might lead to different outcomes because the LLMs work differently and have been trained differently. Once the AI model finishes executing, it spews out some text. If we set up a structured output, it will try to map that text into the structured output that we configured. And we will then have the opportunity to store this extra interaction as part of our memory if we want to keep track of interactions. So if our agent needs to understand the past, then we need to store memory here, and we will use that memory in the build messages part. If our agent doesn't require prior knowledge, then we can actually just delete the store memory and the retrieving of memory, loading memory early. Okay. In the end, our agent, our AI model returns something. That is the outcome of our agent. We return that to the caller. Okay, and this is the gist. What Agent Workbench then does is simply implement a service action so that we can call this from our applications. Okay, and return the output. Final thing that I wanted to mention before before moving on. Orchestration. So if we have a situation where we have multiple agents to tackle different tasks, but we want to coordinate them in order to come up with the solution to our problem, then we can use workflows. So that is how the strategy that OutSystems has been promoting. We can orchestrate multiple agents using workflows. This example in particular actually is an option for your exercise later, but it uses 3 agents to come up with a title, a priority, and a category for an issue, solely based on its description. Okay, and the idea here is that these 3 things are independent. We can run 3 agents simultaneously to get independent information. They can update the issue independently. In this case, we're not using tools. We're doing it in the workflow itself, but we could have used tools inside our agents. And once all the updates are complete, so once we have generated the title and assigned it to our issue, assigned a priority and assigned a category, then we can mark the issue as it's fully ready. We can assign it to some employee to deal with. Okay, so if we have more than one agent, specialized agents, there are multiple patterns of interaction of orchestrating agents. This is an example of a parallel execution. Others could include having checks like human activities here, where humans are added to the loop to guarantee that the agent's outcomes are correct, are valid, and we can proceed. It could be something that there's a sequence of agents that work on the previous agent's output in order to enhance it or improve on it. This could be a loop, etc. So we can have a lot of different approaches here, but workflows seem to be a natural way of orchestrating things. Okay. And with this, I conclude my presentation. Oops, I went one further. Oh, bummer. Sorry. Why did I? Sorry. Give me just a second here. But we can answer questions. That's the point here. Before I show you the other slide, let me just share my screen again. I lost it.
George?
Okay.
Here's a great question from Victor.
Okay. ChatGPT was down for a day a few weeks ago, along with my app in production. Oops. So what is the best way to set up a fallback model? Is it okay to set another provider as priority 2 and 3 in the same model connector? I don't think you can have multiple providers for the same model connector, but your agent can use different, or as in your implementation, your agent flow can use different AI models if one is not available. The concern there is that the prompts might not work exactly the same way for different providers. Okay, so how Haiku works or ChatGPT works or Copilot works with the same prompt is going to be different. Okay, or can be different, which means that if you have a model that works or an agent that works perfectly fine for ChatGPT, it might not give you the exact same outcome if you use one of the other models. Okay, so that's going to be the concern. But you can implement logic that chooses to use another AI model. Okay, if you go back to our to this example here, call AI model is where you're going to call the whatever is the ChatGPT, for instance. So if you detect that ChatGPT is not available, you could revert to calling another AI model. So this call agent can use multiple modules. It's just models. It's just a matter of choosing it. On exception, well, on exception would not go back to this flow, and you might want to come back to this flow. So one option is that you put the call AI model inside an action with the on exception, so that you can capture the exception without breaking the execution of the agent flow. And if you find that the model call failed, you call a different one. Okay, that would work. It's an option. Okay, and you would want to log that information as well. So one thing that I didn't put here, because it's not out of the box implemented there, is that there are you should be logging a lot of things. So here we're storing the inputs, the requests and the responses to our agent, to our AI model. This is something that we should keep logs of, auditing logs of, because that's how we will go to understand how our agent is working, what made the agent do certain actions or choose certain outcomes. Okay. Other questions? Yes, I bored everyone so much that only Victor has questions.
Looks like it. Oops.
Okay, so let's get down to work. And my intention with this exercise was to give you a bit of free rein. So I kind of made it. There's several options here. So there's a hands-on now. I'm going to try and do some interactively. I might build one of the options. But the idea is that we have a base application that already does some things. Namely, it allows you to create issues. But there's some things missing. Okay. The application, you can click, if you have the PDF, you can click on the QR code and it's going to open the download location. You can download it from there, or you can scan the QR code and download it. This is an application that you need to publish in ODC Studio. And if you open the app, on a browser, it lands on a page that explains the exercise. Okay. So let's see if I can actually show it to you. Let me see. If I in my browser. So here's browser. I'll share in a moment. And I have okay, so I'm trying to share something. I'm not sure I'm seeing it correctly. Present something else. No, not this. Login, this one. Okay, cool. Okay, so let me just log in. Forgot to put it anonymous, so it's actually no. I needed to have a. Keep forgetting the password.
George, are you okay if I paste the URL?
Yeah, it's fine. Okay. Yeah, no issues. Okay, so you'll get something like this. This explains the context of the problem and gives you the challenge, gives you examples of a system prompt, which I purposefully didn't give. You can see an example here. You are a grammar checker, so it's basically saying what's your role, explaining what's your job, and what should you use in order to perform it, and tells the agent what should be the outcome. Okay. And the user prompt is I ask a question. What is the question that I'm asking? Perform grammar check for this article, and then you pass on the information that you received from the user in this case. Okay. Now, I have two approaches here, and you need to read all of this. Do one single agent and use structured output. So one agent is responsible for finding the title, what's the category, and what is the priority for an issue. Or you can have, like I had in the screenshot there for the orchestration, 3 agents. Each one does one single thing, and our workflow will be responsible for orchestrating. Okay. If you want to use tools, I didn't on purpose, but if you want to use tools, you can use in either of these variations. You can configure the tools in the AI model itself, on the agent, so that the agent can perform those operations. So you have the instructions here. This is the base application that you potentially actually don't need to change. Depending on your approach, you won't need to change. But if you want to, feel free. It's out there. The idea is that you add on to it. Okay. And what I'm going to do here is I'm going to slowly build one of the solutions. I've already have a solution with an agentic system, so I'm going to try and build one with a single agent. And if you have questions along the way and you want to share your screen, or I'm not sure you can share a screen, but if you have questions, feel free to ask around. I'm not going to give you the prompts directly. That was on purpose. So I want you to build the prompts based on this kind of example. Try to figure out what's the right prompt to get a title that is a summary of your description. What is the category, and what are the available categories, etc. Okay. So I'll leave it to you. I will continue to share my screen as a way of sharing what I'm doing, so you can see how it would work. But the idea is that you guys do some of this work and you can explore. That's why I didn't go into step-by-step instructions like usually do on training. I wanted it to be more flexible. Okay. Regarding token consumption or costs, a single agent is more efficient than the agentic system. It depends. So depends on a lot of factors. In this case, I think it's probably more expensive to have multiple agents, but it depends on the scenarios. So what costs tokens? The request and the response. If the response of the 3 agents is basically combined when you do it a single agent, then the response costs the same, and it's the request that might be different. Okay, so how larger requests, more tokens, and if we have 3 agents and they share part of the of the requests, like the system request is similarly worded, we might have benefits in having a single agent. When it comes to cost, there's 2 metrics that are important here for Agent Workbench. One is token consumption. This is a cost that you pay to your AI model provider. So think OpenAI, Anthropic, Microsoft, Amazon, etc. And there's another cost that is agent calls. And this is an OutSystems cost. Your license will come with a certain number of calls per month. And if you exceed those, then you go into more cost. So if you have 3 agents and you don't need to, then you'll consume 3 times the calls. Okay, even if token consumption is not that different between 1 agent or 3 agents, depending on scenarios, the calls will be okay. So it depends on the situation. The more an agent does, the more risky it is that it's going to go crazy. Okay, keep that in mind. You need to kind of narrow down the scope of what the agent will do, because agents are not trustworthy. The more information you have, the more you ask of them, the more likely they will come up with interesting answers. Okay, so having simpler agents could be a good strategy to have better or more correct outcomes as well. Okay, so let me share my full screen just so you can see. So our issues, we can create issues here. Like when we add an issue, we just give it a description. Okay. And let me just see if I can. Okay. Let's see. So I'm going to show you this at work. It's an example of an issue. Dashboard page takes more than 30 seconds to load, affecting user experience significantly. I'm going to submit. And you can see that it doesn't have a title, doesn't have a category, nor a priority, and it's in the state created. Okay. So at this point, my agent might actually be already working. There's no feedback on the UI, but it might be working. Because when I created an issue, I triggered, the application triggers an event that is being handled by the workflow, and your agents could also handle it eventually. And at some point, all of a sudden, we will have a title, category, and a priority if everything works correctly. There you go. Okay. Profile page layout broken on mobile devices. This was summarizing the information that we passed as a description. It's me, the requester. It's a UI enhancement. Actually, it's not this one. Sorry, it's this one. The dashboard page takes more than 30 seconds to load, affecting user experience significantly. Dashboard page, slow loading performance issue. It's a performance optimization, and it was considered high. So this is the agent at work. So what am I going to do now is publish an alternative one. So I have another application. Oops, not this one. Bummer. not what I wanted. Made a mistake here. I have an issue tracker. Let me just clone it so I can have it independently. And my first approach was an agentic system approach with a workflow. The example on the slides with 3 specialized agents. This is a scenario where I'm going to try and have a single agent with a simpler structured output as well. So let me publish this. So I can use it. I'm going to create a new agent. Let me just delete the other agent that I just created for no reason. Okay, so back to my application. So here I am going to create a new agent, new agentic app. I can call it issue completer agent. Agent responsible for filling out the missing bits, missing details in a. Okay. Use Claude again. Very important for all the agents. Make sure that you have descriptions for everything, because that is one of the major ways agents have of understanding what things do, including structures, attributes, or even actions. Okay. So I have a call issue completer agent that has an agent flow, get grounding data, build messages, call, and store memory. So I know I don't need memory, so I'm going to delete right away the memory stuff. So store memory can be deleted because it's not multiple interactions. I just have one interaction, that's it. And in my build messages, if I go inside, there's this section at the bottom that has to do with load memory and append memory to messages. I don't need these two. I can delete this. And actually, I can also delete the message to store in memory. I don't need it. I can just delete it as well, because I'm not going to store anything. Okay, so that's it. I just removed all the references to memory, which means that these actions are not needed. Can delete them. And on the data tab, there's also the memory here that I shouldn't be using at all. Let me see. I'm not using it, so I can delete it as well. Okay, so no need for memory. Now, grounding data. Let's start with the system message. So here we have our system prompt, and the prompt here says, "You are a helpful assistant." Okay, you're not a helpful assistant. You are a issue completer agent. Your job is to fill in the missing title, category, and priority of an issue based on its description, the available description. So priority should, let's see what the issue tracker says. Priority based on the issue's urgency. Actually, I'm going to copy this bit here. Should be based on the issues of the issues description. Category should be chosen from the and chosen available. Okay, so this is the part where I am writing 3 prompts in one. So it's going to be a longer prompt, so more tokens. Might still be a bit less than 3 separate prompts or not. It depends on how we're writing it and how we need to write it. But category. And title should summarize the description in no more than in 10 or less words. Let's see. The title should be a the description in 10 or less words. This is the part where I want to have structured output. So I'm going to say output should be returned in JSON format. I can write some structured format. So for instance, I can say title for instance, and then I would have also a priority medium, and I would also have a category. Let me check an example just to make sure that I use an existing one. I don't know what the categories are. Let me check. Let's say security alerts. Security alerts. Let's pretend it's security alerts. This is just an example. It doesn't really matter if these align with the existing categories, okay? But this is and agents tend to write justifications, so let's make sure that it don't. Okay. So this gives the role, gives the job description, and then gives more context on how we want the work to be done. Okay. And this explains what's the output. Okay. Done. And now I'm going to add a structure that matches what I've just described there. Okay, so I'm going to create a structure, outcome, issue details, title, category, and priority. Okay, so I have this, and this is not being used. I could write descriptions here, but what I'm going to do is I'm going to go back to my agents call. So I can go here, I can go to automations, and you'll have agents here as well. I can double click here to configure our agent. I'm going to call structured output. And here I'm going to add a structure. I'm going to say that's the issue details. And now I can give a description. Okay, it actually writes there as well. So and summary of the description. No more than 10 words. Instance, category. Description of type of issue, and business impact. Okay, so we have this description will help the agent identify what it needs to do. Okay, we still have an error here. And because I changed the structure, now we need to change the output of my agent flow because it's no longer just text. Now it's a structure. So we need to come here to the response of the agent flow and say that it's now a structure. Issue details. Okay. And it's now not contact text. Just the response. Okay, so it's now returning just one structure. Okay. Well, it is helpful. The descriptions are helpful for us, and now they are very useful for AI. So, yeah, it's a meaningful side effect of using AI. Okay, so we have text data type required in issue details. So here we have the same issue. We need to, our response is now a structure, which is the issue details. Okay. Go back here. So here our system message is kind of complete. Now we need grounding data because we need the information about what are the available priorities in the available categories. So you can go to grounding data, and we're going to, based on user input, obtain the grounding data. Now the user input so far, we've been receiving a text, but what we actually want would be an ID of the issue, right? So let's change that to be an ID. And actually, we don't even need any user input. The ID could be the session ID as well. So we don't need both. There's no session. So I'm going to say that this is a issue identifier, which I need to reference. And what else? Get issue description. So I need to receive here an issue descriptor, issue identifier. I don't need a session because we don't want to keep session information. We do need to know multiple interactions. So we can delete all references to our session. Agent flow, can delete this. Our agent flow also does need the session. Now, whenever we have a user input, I'm going to change it to be a issue identifier because that is what's going to be meaningful for us. Okay, so issue identifier. And now on our grounding data, what do we need to do? And I already imported what I needed. So the first thing we need to do is, okay, this agent gets called whenever there's going to be a new issue created, and we pass it the ID of the issue created. So we need to fetch the information. That's the first service action that we have available from our main application, which is it receives a issue ID and returns the description for that issue ID. That is important, right? Actually, this should probably be major in the main point, but get issue description. Next, we need all the categories and all the priorities. And these are actually entities that are public. So let's make them static entities. And we have category from the alternative issue tracker and priority from the alternative issue tracker. Okay. Which means that now we can just do an aggregate. Get all priorities. Yeah. Get priorities, fine. Okay. And I also want get categories. Confusing. So I have these two things. Now my grounding data, I could just return text, or I can, in this context, not translate it to text yet and do it at a later stage. We can do both. It depends on how we're going to build our messages afterwards. I tend to prefer not to transform this into text right away, but in many situations, people will prefer to just generate the grounding data in one single location, with one blob of data, and add that. So I'm going to do it in a slightly different way, because build messages here is using as grounding data. And if it's not empty, it will add it, right? So we can do that, but I will need to add one thing, which is there's another output, which is description. Okay. So what am I going to do here? I'm going to turn this get priorities into a JSON, so text. Get priority is going to be serialized. Serialized priorities. Do the same thing for my categories. And in my grounding data, I'm going to say and then I'm going to pass it the serialization of categories. Available priorities plus serialize priorities JSON. Okay, so I'm adding context about what's available for in terms of categories and priorities. And I'm also going to return the description. Okay, so that's my grounding data. I don't need this. And since I have my grounding data, now when I come here, it will add it. Okay. And we can decide how to do this, but this is an option. Okay. Okay, and as you can see here, it says this is the grounding data, and then it uses the system message context. And now, if you scroll down, so it's adding the messages. This part you can delve into it afterwards, but later on here, it's where it sets up the what is the user prompt. And in our case, our user prompt, we want it to be a bit different than just what we receive. We want something like missing title, priority, and category for this description issue. And then we pass the description that we have, which we calculate in the grounding data. So it should be here. Actually, I didn't receive it. So let me in the description. In our agent, this one needs to receive the description now. We can delete this. Okay, so now our agent doesn't use the user input. And here it will use the description. Okay, so at this point, we seem to have, we created the system prompt. We added the grounding data based on the priority list and the category list. And we added the generate this. Unused user input. So, and now we call our Claude. It returns this. What's this? And our response is going to be a structure that is going to be sent back to whomever needs it. Okay, so we can publish. Okay. Getting too happy with the possibility of adding comments to publishing. Okay, so how does this work? So we could have done this two ways. So we could have said that this agent is triggered by an event that is being actually, that it would handle the event that's being triggered here when we create an issue. But we are going to say that we are handling the event here directly. And we are going to handle it with a new action. And the new action is going to call the agent. So service action, call issue completer agent. Nope, I'm not going to talk about agent guardrails. I know. We are not going to discuss that. Of course, there's too many things that can go wrong if we're not paying attention to those kinds of things. But that's too much to ask from a quick workshop where the goal was to actually do something. So I'm not going to do that, sorry. The same thing as just adding stuff to the database that you receive directly from the user, right? So it's probably even worse here. Okay, so what am I doing here? On creating our our issue, we trigger an event, and we're going to handle it in the same action that triggers the event. And the first thing that action does is, let me call the issue completer agent so that I get the rest of the details. And the next thing I'm going to do is, I'm going to fill out the rest of the issue with, well, the ID that I know and the title that it should be received from the agent. And also, it doesn't show here, but on my, so here we have a issue potentially, depends on how we build our agent. Our agent is returning 3 texts. Potentially the name of the category. Okay. Now my category, if you come here and check what the category does, category has several different things here, right? Has an ID, a name, a description, order, and is active. And we are sending all this to the agent. I didn't simplify it, so I'm serializing the whole thing. And I'm returning, I want the agent to return the name. But maybe what I actually want is for the agent to return the ID of the category. so that I don't have to read it here. So I'm going to go back to my agent. And here in the build messages, I'm going to say that I want category ID. I'm going to say 5. And priority medium, I'm going to say like 3. Okay. So hopefully this will mean that the agent will return the ID of category, but I can work on that because my agent, I'm configuring it to use this structure, right? ID of the category, the identified category based on the type of issue. And here, oops, I can say the same thing. ID of the priority urgency. Okay, so I changed the description. I need to change the data types as well. So go to the structure, category ID. It's going to be a category identifier and priority identifier as well. Okay. I think we're probably ready for the Kahoot in a moment because vague idea that this was an hour and a half affair. In any case, once I finish my agent, I can actually try and see if we can fill it up. Okay. Oops, already updated. Category and priority. Just checking something here. On my logic. Okay, so information is correct here now. Call response category. Let's see here. We'll change this so it kind of reflects the original name. Oh, we cannot change. I didn't change the name. Oh. Change in the wrong place. Sorry about that. There you go. Publish. This one also already issued. Fill, and after that, if I filled everything, then I can also just call the issue open, which will change the status of my issue to be open. It should be enough. Let's see if it worked. Okay, open browser. Hopefully it works. Let me. Okay, great. Usual thing. Keep. Oh, not OutSystems.com. No permissions because it's a new application. Okay, let me just. Actually, let me just open this one. Let me go end user groups. I have a group where I put everything. Let me just add an application. Alternative issue tracker. Okay, so now I should have access. Okay. And if I go to my issues, I have no issue. Let me see if I can get another one here. Something that is really terrible here, this one. See what happens. Submit. And actually go to our. There you go. So software bugs, critical, and payment gateway transaction processing error. Okay. And now, for one, I can change things.
Awesome work, George.
Are we good to do Kahoot? I'm not sure what time this finishes, but
Yeah, so we've just got time to do the Kahoot. So
okay.
you smashed it. Well done. Thank you. That was a fantastic explanation and a fantastic exercise. I hope everyone went and did the exercise as well. That was great. Margaret, are you able to help us out and share the Kahoot?
Coming right up.
But again, that was brilliant, George. Thank you.
Thanks, George.
And I'm not going to join the Kahoot today. So if go to like kahoot.it, put in the game pin, put in whatever name you like. If you want to put in Stuart Harris, then that'd be awesome. Might win something.
But you have to say a dad joke before you get your prize.
Yeah, do we have to? Do we have to do that to people, Margaret?
Well, yeah. Okay, that's fine. We can remove that rule. I'm easy.
If it's a bad joke, we could say you're not going to get the prize.
Yeah, true.
That might be a bit unfair too.
True.
The world's just a difficult place, isn't it? All right, I think we'll give it a few more seconds, shall we? Get comment from Anandi. It's a wonderful session. Thank you. It was a wonderful session. It was great. Really nice example too.
It had to be simple as well. So.
Yeah, simple, but as complex as time allows. Yeah.
Yeah.
All right. I think we're good to go. Don't want to keep anyone later. All right. Here we go. Let's go, Margaret. All right. Which of the following is not related to agentic AI? Agents can perceive context, act with a tool, decide the next step, or dream of a better future. Excellent. Right, well done, MG. MG's on top. Sunil close behind. And Anandi, good work. Come on, AC and Victor, and everyone else. All right. Next up. Large language models have no memory, can answer any question, always gives correct answers, never forgets. Oh, that was a tough one. And Anandi's listening skills are clearly the best. Victor's shooting up there, so is Teresa. MG, what happened? And Gil, nice work. And Liz was the highest climber. Come on, Liz. Where do you define an agent's goal? In the user prompt, in the system prompt, in the memory, or in the prompt reply? You see those images there. Oh, nice work. Nice work, everyone. Well, except for one. Margaret drew those images by hand that we're seeing there too. She's really good.
Yeah, Margaret AI. That's coming next.
Oh, Victor. So when you're doing this, the speed at which you answer also helps get you to the top, but it can also help you get the wrong answer. Well done, Victor. And Andy, Teresa, MG's shooting back up, AC, and Victor has the highest answer streak. All right, next question. What does RAG stand for? RAG. Retrieve, act, grow, retrieval, augmented generation, respect, amplify, and ground, reflect, adapt, and go back. Excellent. Someone's obviously clicking too fast there. So Victor's still on top, and Nandi's just close behind. Teresa, come on, you can do it. MG. Oh, it was so good at the start, wasn't it? And Victor has another streak of 4. What do you need in order for your agent to remember past interactions? It's built in already. An engaging conversation, memory, a brain. That's right, it was memory. Fortunately, I don't need to answer these questions, so I can pretend like I just knew. Okay, so, right, so that's it. Victor is up the top, Anandi second, Teresa third, MG. I was really going for you, MG. Sorry about that. And AC, well, better luck next time. Thanks, everyone. And so
there's another 2 more questions.
Oh, it's 2 more questions.
Yes.
All right. I thought it was just 5. But so don't go. Anything can happen now. Victor could, fall off his chair. Don't fall off your chair, Victor. Let's multi. All right. It's multi-select. When building the request for AI model, what can Agent Workbench use? Grounding data, user prompt, system prompt, memory. Select all that apply. Yeah, and it was all of them, wasn't it? Oh, Victor. Where's Anandi gone? Well done. Teresa, well done. Sunil, Liz, AC. Okay, so is this the last one now, Margaret? This next
That's
one?
right. Yeah.
All right. You want to build an agentic system in OutSystems, which is not immediately relevant. AI model, localization, workflows, Agent Workbench. I read that really badly, I realize. Sorry, guys and girls and women. All right, so number 3 was AC. Well done. You made it. Teresa, that was a fantastic effort coming through at the end. And who was number 1? It was Victor. Was from number 2 was always on the top. Sunil and Liz runners up. You're all champions. Thank you for coming today. Thank you so much, George. So Victor, Teresa, and AC, Margaret, what do they need to do to claim their swag?
Yeah. So please send me an email if you still have the screenshot of you saying, well done. Please send that through as well. And I'll be happy to arrange the swag for you. So congratulations. Victor, this is your 3rd time, I believe.
Awesome.
You're overloaded with swag.
I think Victor's got an OutSystems store at the market. So congratulations, everyone. Great session. Look out for the next session. If you want to contact us, if you have things that you want to share and talk about, we'd love to have you. George has just demonstrated how good IT Up is at training. So if you need any help, speak to IT Up. They're awesome. Thanks very much. Now you can go and spend time with your families.
Thanks. Thanks everyone for having me.
Thank you. Thanks, Stu.
Thanks, Stuart, for the shout outs for IT Up. Always good.
Of course. Cheers. Thanks, everyone.
Yes.
Bye.
Thanks. Bye.